The major tasks we completed are implement the log parser to be used in a machine learning pipeline, modify the VTM code to toggle partition options based on information from other components, and use Detectron 2 AI to partition frames of video. We did have some modifications to the implementation of the plan. We deprioritized training an AI since connecting the various parts of VTM software to an AI proved difficult. Adding the ability to connect any AI is a significant contribution to the overall project. This is the block diagram for the learning algorithm. My contribution was to extract split decisions from the logs generated by the supplied VTM encoding software. This was done in Python. The original model training has been postponed, and for now we are using a pre-trained model. The log parser is currently used to generate the perfect toggle settings for each macro block. This is used as a benchmark.
Next up, we have the demonstration of my toggle subsystem prototype. The toggle subsystem prototype mainly uses the enable FVC as a boolean to determine if it's active or inactive. If enable FVC is set to 1, then the toggle subsystem is set to active. If enable FVC is set to 0, then the toggle system is inactive. It works. This can be seen in the compressed CTU function, where if enable FVC is active, then you get the xcompress cu alt, which uses alt and next. Alt and next are grabbed from a frame that was created in the log parser. As currently, I am coding frame 0. This changes when you turn enable FVC to 0, in which case this currently gray code runs, and this uses the original xcompress cu, which means it will segment in the original manner instead of the alternate manner.
In the log parser, statistics about the block are extracted by matching the standard formatting of the log information with regular expressions that correlate with the desired attribute. This section is in regards to frame number, block, dimensions, and block coordinates. This is information that is supplied on every line of a block, regardless of the attribute mentioned. In the log, each block has multiple lines for multiple attributes. This section of the code extracts the attribute name and matches the attribute name with the regular expression designed to extract the attribute information. There are over 50 different attributes, and not all are present on every block. The first code section generates a double dictionary structure that stores all of the macro block information. Macro blocks are 128 by 128 sections in raster order over the frame. So there is a predictable outer dictionary index that is related to the y-axis and an inner dictionary index related to the x-axis. The second code section sorts the coding unit blocks inside its related macro block entry in the dictionary so that the partitioning quad tree can be generated. For each macro block generated by the previous section, a recursive call is made to evaluate the blocks of a macro block to generate the partitioning quad tree. Non-leaf nodes represent partition decisions, and leaves represent the individual blocks resulting from those decisions. Each possible split option is evaluated at the node level to see if it can generate the dimensions of the blocks extracted from the log. An example of the split evaluation is presented where the section is evaluated by size constraints, sectioned off according to the split, and sorting the blocks of the parent section into the appropriate child sections. Then the evaluate blocks method is called to evaluate each child section to see if it matches with the dimensions of the blocks until the frame is split to the individual block level. This Gantt chart represents the work we have done during the second semester of this project. Significant amount of time has been expended on analyzing how to modify the VTM code base to allow modification. Currently, we have the ability to enforce partition options per macro block, but still need to generate a pipeline for the AI model to analyze the video and generate observations at runtime. Currently, we have the logs to inform decisions generated prior to encoding.